All right, everybody, what's going on? In this video, we are going to look at finding the area between curves. We have several examples to work. So let's go ahead and get started. So it says the area of the region bounded by the curves y equals f of x, y equals g of x, and the lines x equal a and x equal b, where f and g are continuous and f of x is greater than or equal to g of x. So pay attention to that part. For all x in AB is the area is the integral from a to b of f of x minus g of x. So see here, f of x is larger than g of x over this interval. So a simpler way to put it is the curve on top, which is f of x because it's larger than g of x. So it's the curve on top minus the curve on bottom. And then that'll give you the area between the two curves. All right, so let's look at some examples. So it says find the area of the region bounded by y equals e to the x, bounded below by y equal x, and bounded on the sides by x equals 0 and x equal 1. And actually, this right here should say, I should insert above right here. Find the area of the region bounded above by y equals e to the x and below by y equal x. All right, so whenever you're doing these things, you have got to sketch a graph. Okay, just sketch it. It doesn't have to be completely accurate, but try to get it close. So let's look at the graph here. All right, so if we graph y equals e to the x, and then we graph y equal x, so that's going to look something like this. All right, and also the line x equals 0, which is just the y-axis, and the line x equal 1, which is this. So we're looking for this area right here. So keep in mind, this is y equals e to the x, and this is y equal x. All right, so you can see here that the graph y equals e to the x is above the graph y equals x. You see that? On this interval from 0 to 1. All right. So all we do is we find the area is equal to integral 0 to 1 of the curve on top, which is e to the x, minus the curve on bottom, which is x, dx. And so if we integrate that, we get e to the x minus 1/2 x squared from 0 to 1. So this is going to be e to the first minus 1/2 1 squared minus e to the 0 minus 1/2 times 0. All right. And then whenever you calculate that, you end up with e, and then that's going to be, let's see, e minus 1.5, because you'll have negative 1/2 minus 1. See that? Let me write that step out. I'll do it on this one. That's going to be e minus 1/2 minus e to the 0 is 1, and then that would be plus, and that's 0. And that's going to be e minus 1.5. And if you want, you can punch that into your calculator or leave it like that. I don't think it's going to really make a difference to your teacher. I know it doesn't make a difference to me. All right, so that's that example. So let's look at the next one. It says find the area of the region enclosed by the parabola y equals x squared and y equals 2x minus x squared. So let's sketch the graph. All right, so here's x squared. It's going to look something like that. And now this graph, 2x minus x squared, that's a parabola that opens down. Notice the negative in front of this x squared term. So we know it opens down, and we know it's going to go through this point 0, 0, because if I plug 0 in for x, I get 0 for y. And so it's going to be a graph that looks something like this. And I'm looking for this area right here. All right, so remember, I'm integrating from, well, I see they intersect at 0, and then they intersect right here. So I need to figure out what that value is. And I'll show you how to do that in just a second. But let's go ahead and write this down. We got a equals the integral, and it's the function on top, which is 2x minus x squared minus the function on bottom. Well, what function's on bottom? The x squared. All right. Now, so I hope everybody sees that. The 2x minus x squared, that's the function on top. And then minus the function on bottom, which is the x squared, which is this. See, this function's on top in this interval, 0 to whatever this number is, and the x squared's on bottom. Now, if we went outside that, you can see how it changes, all right? But we're finding the area between the two curves. All right, so how do we get this point right here, or this x value? Well, you just set the two functions equal to each other. So I've got x squared is equal to 2x minus x squared. And so that's going to give me 2x squared minus 2x equals 0. All right. And we solve. So we'll factor out a 2x. And so we get x equals 0 or x equal 1. So this would be 1. See, they intersect at 0 and they intersect at 1. And so that's going to be the limits. All right, so now let's integrate this thing. So we got 0 to 1 of 2x minus 2x squared dx. Just combine the like terms. And so this is going to give us x squared minus 2/3 x cubed from 0 to 1, which this is going to be 1 squared minus 2/3. Let me write that 3 a little better. 2/3 times 1 cubed minus. Now on this part, we really don't need to plug, we don't really need to show this part, but I'm going to, because you know when you plug 0 in for x, this is just going to be 0 out here. Okay, but let's just go ahead and plug it in. So that's 0 squared minus 2/3 times 0 cubed. And so this is going to give us an answer. That's going to be 1 minus 2/3, which is 1/3. And that's your area. All right. All right, so let's look at our next problem. All right, so find the approximate area of the region bounded by the curves y equals x over the square root of x squared plus 1 and y equals x to the 4th minus x. All right, so the first thing we need to do is we need to graph this thing. So to graph it, we get to graph this one. That graph is going to look like this. And then the x to the 4th minus x. This graph here is y equals x over the square root of x squared plus 1. And then the graph of the other one is going to look something like this. And this is going to be the graph of y equal x to the fourth minus x. All right, so you might be wondering, how in the world did I get this graph? Okay, well, I punched it into a computer program and got the graphs. All right, which I am going to show you right here. Okay, so here's your graph. Now what we need is we know this is going to intersect at 0, but now we need to find this. So how would we go about finding that? And your other question might be, well, what if we don't have a computer program to graph these things? Well, I'll explain that in a minute. Okay, so remember, to find where they intersect, well, what do? We take them and we set them equal to each other. Now, this is a very complicated problem to solve. You're not going to solve it by hand. Okay? So you would need to use a computer to solve it, or you can come over here in this graph here, and with this I can insert a point, and I think I can get the point right there, and you see that tells me it intersects the x value right here is at 1.8. So it's going from 0 to 1.8. All right, so we've got this thing intersects here at 1.8. So I'm going to integrate from 0 to 1.8. Now, let me answer the question of how you would graph these things if you didn't have a computer program. Well, do you remember when you graphed for this one, the x and y intercepts, horizontal vertical asymptotes, increasing, decreasing, local max min, concavity, inflection points? Yes, you would have to go through all that to graph it. And same thing for this one, increasing, decreasing, find your critical numbers, local max min, concavity, inflection points, and then you sketch the graph. That's what you would have to do. And yes, it would take you a long time to do it. Okay? So, it is what it is. But, if you have a computer program, just throw it in there. Hopefully, your teacher's not so mean they'd give you something like this on the test. Okay, something difficult to graph. So we're going to have the area is equal to the integral 0 to 1.8, and it's the function on top, which is going to be this one. That's going to be x over the square root of x squared plus 1 minus the function on bottom, x to the fourth minus x dx. All right, so how in the world do we integrate something like this? Well, you're going to have to split it up. That's 0 to 1.8 of x over the square root of x squared plus 1 dx minus the integral 0 to 1.8 of x to the fourth minus x dx. All right, so this right here, this is easy to integrate. This one we're going to need to use u substitution. All right. So for the first part, for the first integral, we're going to let u equal x squared plus 1, and du is equal to 2x dx. All right. So you can see we have the x up here, so we're going to have to multiply by 2, come out here and multiply by a half. All right. If you need to know how to integrate using u substitution, just look in my calculus lecture playlist or search my YouTube channel for u substitution. All right, so this is going to be 1/2, and we're going to have du over the square root of u minus 0 to 1.8 x to the 4th minus x dx. Now, remember, for this one we used u substitution, so we have to change our limits. Okay, remember that? So we have u is equal to 0 squared plus 1, which is 1, and u is equal to 1.8 squared plus 1, and I have no idea what that is. It's what, 2.39, I think. 1.8 squared plus 1. Okay, so I made a stupid mistake, and I mean, I just wrote it down wrong. This is 1.18, not 1.8. All right, so this should be 1.18. Sorry about that. And so now we have 1.18 squared plus 1 is we'll put 2.39. So that's 0 to 2.39. All right. So yeah, I messed that up, but it's fine now. All right. And let's change this to 1.18. So be careful when you're reading the stuff. You know, we all make simple mistakes like that. All right, so now we have 1/2, 0 to 2.39, u to the negative 1/2 du, change the square root to a 1/2 power and move it up, minus, and then 0 to 1.18 times x to the 4th minus x dx. And so we integrate. That's going to be 1/2, and that's going to be u to the positive 1/2, multiply by the reciprocal of the new exponent from 0 to 2.39, minus, and that's going to be 1/5 x to the 5th minus 1/2 x squared from 0 to 1.18. And so this is going to give us the square root of 2.39 minus the square root of 0. That goes to 1 there. Minus, and that's going to be 1/5 times 1.18 to the 5th minus 1/2 times 1.18 squared. And when you punch all that into your calculator, you get 0.785. All right, so yeah, I mean, that problem was a little more involved, but still, it's the same thing that we did in the first one. It's just the functions in this one were a little more complicated. All right, next example. I think we've got 2 more examples to do and we'll be done. All right, so find the area of the region bounded by the curves y equals sine x, y equals cosine x equals 0, and x equals pi over 2. All right, so let's graph this thing. All right, and let's graph. Let's see. We've got what? We've got 2 pi. We've got pi. And I'll tell you what. I'm gonna spread this out some more. We've got 2 pi, pi over 2, 3 pi over 2, 1, -1. And so the sine function is going to look like this. And the cosine function is going to look like this. And then we want the line x equals 0, which is right here, and x equal pi over 2, which is here. So we're looking for this area here. Now, for this graph, notice from 0 to this x value, and do we know that off the top of our head? When is sine and cosine equal? Now keep in mind, 0 to pi over 2, if you look at that, we're here in the first quadrant. You see that? And when is the sine and cosine function equal to each other? Now that's at pi over 4, right? So we know this is pi over 4. That's where they're going to intersect. Because remember, they both equal square root of 2 over 2. So that's where they intersect. And notice here that from 0 to pi over 4, the cosine function's on top and the sine function's on bottom. But from pi over 4 to pi over 2, the sine function is on top and the cosine function is on bottom. So we're going to have to write this as 2 separate integrals. And yes, we're writing it as 2 separate integrals. And I know some of you are thinking, well, do we have to do that? And the answer is no, but I'm going to show you that anyway. And then I'll show you another way that's a little easier to do it. And I'll show you, and I'll explain to you the reason why I'm showing you this longer way first. I'll explain that too. All right, so the area is the integral from 0 to pi over 4, okay, that's up to here, and the cosine function's on top, so that's cosine x minus sine x dx plus the integral, and now we're going to do this region, that's pi over 4 to pi over 2, and the sine function's on top, so that's sine x minus cosine x dx. And then we just integrate it. Okay? So that's going to be sine x plus cosine x, because remember the antiderivative of sine is negative cosine, so the negative and negative make a positive, and that's 0 to pi over 4 plus, and then that's going to be negative cosine x minus sine x, and that's from pi over 4 to pi over 2. And so that's going to give us the sine of pi over 4 plus cosine pi over 4 minus sine 0 plus cosine 0 plus, and now this one, that's going to be negative cosine pi over 2 minus sine pi over 2 minus, and that's going to be negative cosine pi over 4 minus sine pi over 4. Okay, starting to run out of room there. All right, and then, I'm not going to write all this down, but, you just got to know the sign of pi over 4. That's square root of 2 over 2 plus square root of 2 over 2. Well, let's write it down. So that's going to be square root of 2 over 2 plus square root of 2 over 2 minus, and then the sine of 0 is 0, cosine of 0 is 1, plus, and then cosine of pi over 2. Now look, you can get that real easy. Look, remember the red is cosine, and at pi over 2, cosine 0. And so that's going to be 0 minus, and then the sine of pi over 2 is 1 minus, and then minus cosine pi over 4, that's a negative square root of 2 over 2 minus square root of 2 over 2. And then once you do all that simplifying, you get 2 square root of 2 minus 2. And there's your answer. All right, so I hope that made sense. Now, let's go back up here, and I'm going to set up the other integral. I'm not going to work it out. I'm just going to set it up. So remember, and I did the wrong area. It's this area right here. Okay. I'm not having a great day, aren't I? It's this area. All right. So now, how else could I do this? Okay. How else could I find this area? Well, I could also find the area as the integral from 0 to pi over 4. And see, cosine's on top, so that's cosine minus sine dx. All right. Now, keep in mind, this area and this area are the same. So I could find just this area and multiply it by 2. Okay. That's how you would want to go about solving this. All right, that's how you would want to find the area. Just find this area and double it. So why didn't I do that here? Well, you may run across something like this where it changes. The curves change. One's on top and then the other one's on top. You may run into that, and these two areas aren't the same. And if the two areas aren't the same, then you have to do it like this. Okay? But if these two areas are the same, then just find the area of one of them and double it. All right. All right, so let's look at the last example. All right, so find the area enclosed by the line y equals x minus 1 and the parabola y squared equals 2x plus 6. All right, so how do we go about doing that one? Well, notice in this one, the y term is squared, and it's a positive in front of the y squared. So that means that it's going to open to the right. So let's solve this for x. And so I'm going to get y squared minus 6 equals 2x. So x is equal to 1/2 y squared minus 3. And then we also have y equals x minus 1. So let's sketch the graphs here. There's the parabola. And then for x minus 1, that's that graph. And so we're looking for this area right here. All right. Now, how do we go about doing this one? Well, on this one, we want to integrate with respect to y. And all the other problems, we integrated with respect to x. But this one, we want to integrate with respect to y. And yes, I need to know where these things intersect. But since I'm integrating with respect to y, I need the y values of where they intersect. And so what I can do is I can set the two functions equal to each other, or the two equations equal to each other. But when I do that, I want to set them equal where it's all in terms of y. So I'm going to take this one and I'm going to get x is equal to y plus 1. And I'm going to set 1/2 y squared minus 3 equal to y plus 1. So I've got 1/2 y squared minus 3 equals y plus 1. And so that's going to be, let's see what we get. We get 1/2 y squared minus y minus 4 equals 0. Multiply everything by 2, so y squared minus 2y minus 8 equals 0. And then this factors y minus 4 plus 2, so y equals 4, or y equals -2. And so this is going to be -2, and this is 4. All right, now we need to set up our integral. So the area is equal to, and that's going to be from -2 to 4. Now, how do we set this one up? Remember, when we were in terms of x, it was the function on top minus the function on bottom. Well, for this one, we're integrating with respect to y, so it's going to be the function on the right minus the function on the left. So the function on the right is this y plus 1. See, the y plus, or this y equals x minus 1, which we have to put it in terms of y. So that's, we're going to have the y plus 1 minus the function on the left, which is this one, which is the 1/2 y squared minus 3 dy. And so that is going to give us -2 to 4, and that is going to be -1/2 y squared plus y plus 4 dy. And so here we're going to get -1/6 y cubed plus 1/2 y squared plus 4y, and that's going to be from -2 to 4. And so this is going to be -1/6, 4 cubed, plus 1/2 times 4 squared, plus 4 times 4, minus, and now we plug the -2 in, -1/6, -2 cubed, plus 1/2 times -2 squared, plus 4 times -2, and you can put all that into your calculator if you want to, but you end up with 18 for an answer. And that is finding the area between curves. Okay, so you learn some techniques there. Function on top minus function on bottom. And then if in that interval, the function on top and function on bottom, if it changes, you need to split it up. Split the integral up like we did in this example right here. But remember, if the areas are symmetric, you can just double one of the areas. And then we have one where our functions are in terms of y. It's the function on the right minus the function on the left. All right, so I hope this helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching. I'll see y'all later.